To make my clock smart, I'm going to need to pull data from Google Web Services. That's the Pico 2W's responsibility in this project. How to do that? Well, my process might surprise you. Hi, I'm John, your concierge to the world of the Raspberry Pi, Pico, Pico 2, robotics, IoT and other fun slices of tech. So I'm doing this Secret Santa project together with 3 other YouTubers. You probably know them, Kevin, John and Dan. In this video, I'm digging down on the smarts of the project, if you like. Those web services for geolocation, geocoding, weather and weather forecast, as well as YouTube statistics too. 4 quadrants of data. Quite a few web services calls, I know, to fulfill all that data. If this video sparks your inspiration or helps with your projects, consider dropping me a tip using that super thanks button below the video, or alternatively there is a payment link in the description. It helps support the channel and keeps these videos coming. Please remember to subscribe and like the video too. This video is sponsored by WolfSSL, the embedded TLS SSL library, trusted by over 2,000 commercial and military projects. If you're building secure web services on constrained hardware, like I am, WolfSSL is your friend. It's fast, lightweight, fits ready and plays beautifully with embedded stacks like FreeRTOS, Zephyr and even bare metal. I've been hands-on with their WolfCrypt crypto engine and it's refreshingly remixable too. You get full control, clean APIs and serious performance, whether you're securing IoT endpoints or spinning up HTTPS web services on a microcontroller. WolfSSL makes it doable. Hit the link below to check out the free trial and development resources. And if you're serious about embedded security, this is where to start. So this video is a deep dive into my Secret Santa with these guys. So we've got Kevin and his wonderful robot and robot builds. We've got John, Steamhead, with his sculptured robots and productions, and Dan with his companion robot. And it's Dan that I'm building for in my video. Everything I've built for this build, I've shared on GitHub in this repo. So this is really a 3-component build. We've got this RP2350 2.8C screen from Waveshare. I've got an AHT10 humidity and temperature sensor, and then I've got a Pico 2W. And it's just combining all of those that give us this wonderful build. I've talked previously about the screen and the AHT10 and how they work together, and I'm going to do a deep dive on actually how to code the LVGL side of this project. But in this video I'm going to focus a little bit more on the Pico 2W and how that works for web services. Remembering that's actually publishing its data over UART back to the screen so that the screen can show all of the information, including what the actual current time is. The Pico 2W, well actually that's really just focused on talking to the Google Cloud and its services, and quite a lot of services. So we're doing geolocation, because I need to know where you are to know what the time is. Geocoding, because I quite like to know what the name of your postal town is and where you are. Weather forecast, because I'm British and we want to know what the weather is. And YouTube data, because I'm a YouTuber and I need to see those stats. Now to access those web services from my Pico 2W, I'm going to use quite a lot of libraries from the wonderful world of the World Wide Web. So we need the SDK, of course. We're going to need LWIP because I need an IP stack. I'm going to need FreeRTOS kernel, partially because I want some multitasking and partially because I actually want sockets available to me. And it's those sockets that I'm then going to give to the FreeRTOS core HTTP service so that it actually can run HTTP requests for me to get those web services back. Now those are going to be secured via TLS, so I'm going to use WolfSSL as my TLS library. Now I'm going to actually encode everything and give it actually URLs, so I need a library that's going to decode the URLs for me, and I'm using the URI library for that. And the data I'm getting back is going to be in JSON, so I need tiny JSON to be able to parse that. And I'm actually going to then make JSON to actually send over to the screen, so I'm going to use JSON Maker. All of the services, so that I can call web services, I'm actually going to combine into one library and one function called the Pico WS client, which is my own library. And I'll come back to that in a minute. And finally, I'm going to store some things like my Wi-Fi credentials, my Google access key, etc. in my NVS, non-volatile storage, on the Pico 2W, which basically means I'm using part of Flash to hold that data. Now, the libraries aren't quite as complicated and to worry about, certainly from the perspective of this video, because actually we can just group them. So yes, okay, there is a bit of stuff that we're going to need to do around the FreeRTOS kernel. We need to be aware of the JSON libraries. Most of the things doing web service client calls and getting results back, actually that's all hidden from you behind the WS client library that I've written, and we will need the onboard NVS library. If you want to know more about web services, and why wouldn't you, and how all of those libraries work to be able to call them, I'm not going to go into that here. I've got a course on Udemy that goes into that. The reason I'm not doing it here is it's 12 to 20 hours worth of course and content that I just can't publish easily on YouTube. So I'm afraid it's over there on Udemy. Please go and try the course. Of course, everything I'm talking about here we're going to run in C and C++. But is C and C++ where I would suggest you start with these web services and exploring them? No, don't. That's a mistake. That is much too complex to work on these, I think, from inside a microcontroller initially, until you understand what that service is, how all of these services are going to connect, and how you're going to use them. So my recommendation and my approach is always to use Python first on my desktop. So I write a whole load of experiments which actually go and call these web services, get the results back, and I use those results in order to then inform the design of my C and C++ code. And I find that speeds things up massively. All of these services are going to use an API key that you need to have got from the Google Cloud, and they also require that you provide that Google API key with permissions to call these services. If you don't do that, the services will all fail. Let's start with the geolocation web service. This is key because everything really requires we understand where you are, and we're going to look that up by your IP address. Without the location, I don't really know your time zone. I can't find out what the weather forecast is for your location or any of that data, sunrise, all of that. So we're going to use two services here. We're going to use geolocation to get latitude and longitude, and then we're going to geocode that in order to get your postal town. So in the repo, I've got a EXP folder, which is part of my development process. And it's where I write experiments to test stuff out and make sure whether it works or not. So in here I've got a PY for a Python folder, and if we have a look here, we've got a geolocation program, and this is going to test out this geolocation URL and web service from Google. It's going to need the Google key, which I'm pulling from my environment, so it's held as an environment variable, so I don't have to put it in the script, and I also don't have to put it in my code because it will actually get built in automatically through the process that I've run. And then that's going to basically use the request object to post that URL, get the response back, and then I'm going to print it out. Now, I'm just diddling the data a little bit here so that I don't give you my exact location, because that seems kind of wrong. So there's just a little bit of error here that is going to add in just for me to show this to you online. So as you can see, this is the output as it runs, and we get back basically a latitude and a longitude and an accuracy. Don't care about the accuracy, it's the latitude and longitude that we need, because that's what I need to be able to run some of the other functions. So let's have a look how we process that then in our source code for on the Pico 2W. And so in the Pico 2W's firmware folder, we have a whole load of WS classes, and these are what I'm using to schedule as functions to go and get that data. So let's have the WS location, and you see when we create this object, we are going to give it a key, which is a Google key, and then at some point we're going to ask it to update the state value that I'm holding within this. So I want it to basically update the geolocation information that we're holding. So if we have a look at the code here, we've got that URL once again that we just seen in the Python code for geolocation. I've also got one for geocoding. We'll talk about that in a second. So I'm going to set up here how we're actually going to process it. So we're going to need some JSON structures to be able to pass the values that come back, and we're going to need our query, and the query is going to need to have our key in it that we're going to pass into that URL. And then everything really gets done in terms of the web service by me asking a request object, which I've been given, which is a library structured method object that I wrote for web services in my course on Udemy, and it's that's actually going to initiate the post and get us the data back. So you see I've got the geolocation URL in there, and I've got so I've got the geolocation URL in there, and I've got the parameters, and I've got a query. So all of the information I need in order to initiate this as a post request. The parameters are empty, the query is going to have that key in it. So if this exceeds, i.e. the code's going to be 200, we're going to keep running down, and we're going to basically create a JSON structure to be able to pass this. And in passing this, we're going to look for the structure location. In location, we're then going to look for the structure latitude and longitude, from which we're going to basically pull a floating point number, and we're going to store that in our state data that we're holding within this code. And that state data will then get pushed out and sent over to the clock. So once we've got location, then we can go on to actually run the second function, which is to look for our postal town. And we can do that by running another web service, and we're going to run a web service called the GeoCoding. Let's have a look at how this looks first on my experiments. So if we have a look at where, which is basically going to run the geocoding code and find where we are. So geocoding requires that we give it a few parameters. There's the URL. We're going to give it, of course, a key. So there's a key in there. We are going to give it a ask it for a result that is postal town. I'm going to try and keep down the amount of data going back to my Pico W. And I'm going to ask it for a give it also the key and the latitude and longitude. The latitude and longitude aren't given here as separate parameters. They've sort of been combined with a comma between, which is a little odd in the call to this, but that's basically what we're going to do. So I'm going to do exactly the same then in my code over in WS location. Here we go. So I'm basically setting up, going to say, can I have a result type of postal town? Can I have a latitude and longitude? And I've pre-formatted the latitude and longitude data, and I'm going to give it the Google key, and I'm going to run that. This one is actually an HTTPS GET, And again, if that succeeds, then we can start processing the output. Now the output's a little bit more complicated here, so we need to pass through a structure of results and actually go through a bit of a loop until we can find something called a formatted address, and within that, basically the postal town that I'm going to pull out. And that's how I'm sort of getting to that and how we're getting and processing that data. Now our Pico W is actually going to set the time as it's displayed on the clock surface. And it's going to need two things for that. It actually needs a time in UTC, Universal Time, but then it needs to know what the offset to that is for your local time zone. And so we're going to use a web service in order to actually get that offset. I'll also bring out the name of that time zone as well. So let's have a look at that one. So the time one is pretty simple. So time is going to hit a time zone, basically web service, and that's just to work out whether you're in daylight saving time or not, and it's going to get the name of the time zone that I'm not actually using it at the moment. So in order to hit this one, we will need to give the parameters of our key, and we will need latitude and longitude, unsurprisingly. So I'm setting those up, and then we can initiate the request into the get time zone. Oh, actually, there's also timers required in seconds. So I'm pulling that of my understanding of time based on the SNTP. So we can put a timestamp in seconds in there. I'm just calculating that. So then we can call that, and back should come the data giving us the time zone and the amount of offset from that. And then I'm basically just going to go find that offset, and we're going to store that as the offsets. So I'm going to add the destination offset and the raw offset together to give me the full offset that I'm going from UTC. And that's what I'm going to store as the state and pass over to the clock. So the clock, then I will pass it both UTC and offset data. Now the time itself, of course, we're getting that from SNTP. So all of this code really is about just pulling the time zone information. The weather now is actually quite a simple web service for us to pull back, though it comes back with a reasonable amount of data. So we're going to call a service called current conditions, which is going to give us temperature, precipitation, wind, everything we really need. So the weather now is also quite a simple web service. All we're doing is we're doing the current conditions lookup web service and pulling that data back. That's again going to need a location. So I'm going to add a location into our parameters. This time the latitude and longitude are stored as separate parameters. Now the way that my library for calling these web services works, you can only put query parameters in as strings. So I need to do a little bit of conversion here just to convert the latitude and longitude into strings before I can apply it into our query. And then we can call that this URL for weather, or the current conditions URL. If it succeeds, then we can start processing the JSON for this. Now there is quite a bit more JSON that comes back on this, but it is just a process of navigating our way through that JSON in order to pull out, is it daytime, is it not, what's the current temperature, which is held in a degrees value, what the relative humidity is, to go in to get the weather conditions out, type description, precipitation, wind speed, wind direction, there's precipitation, quantity of precipitation, probabilities, just really navigating through that JSON in order to pull out those values that I want to store in my state object, and then I can pass them over no different to what we've done previously, just a bit more data. The weather forecast data, well, that's again just a single forecast web service. It is slightly tricky in the sense that it actually throws back a huge amount of data that we're going to need to handle. But we're just going to extract the data we want and then place it in our state object to send over to our screen. By far the biggest single web service I'm calling in this is for forecast. And forecasts, which is that request there, even though I'm going to restrict it and say I'm only interested in the forecast for 1 day, please, is still a massive amount of data that comes back. As you can see here, it's scrolling up the screen. There's quite a lot of data that we're going to need to sift through. And some of it's stored in arrays as well, which means there's going to be some loops to look through it. But once again, we are of course going to need to have our location in order to work out what the forecast is, because we want the forecast for where we are. And again, latitude and longitude are stored as separate query parameters. And we also want the number of days we want to look ahead. I really can't afford to look any more than 1 day because it's just the amount of data that will be thrown back at us. So here we go, and once we've got that value back, we can then start going through and looking for what is the temperature, is it daytime or nighttime, etc. So that is one other good point. So what is thrown back here is 2 forecasts, a daytime forecast and a nighttime forecast. So what I've done here is said, well, actually, I'm only going to hold one of those in state. And what I'm going to say is if you're after 1700 hours by our time, then I will assume that it's nighttime and give you the nighttime forecast. If you're in the daytime, so you're after 5 AM before 5 PM, then I will give you the daytime forecast. And that's kind of hard-coded. Probably that should be a nice parameter somewhere, but hey, that's how I've set it up at the moment. So yes, and then it is just processing our way through that JSON to pull all that data out. You'll see that I'm basically storing the same types of parameters that I was previously, though the JSON I have to navigate is a slightly different structure. Oh, and finally on the end of this, there's also the sunset and sunrise time, and I'm going to pull those out. I toyed with the idea of pulling moon out, but one, I found that I didn't have enough room on the screen to put it anywhere, and secondly, moon's slightly awkward because it's an array which could be 0 rises or sets within the day, so it's kind of slightly more tricky to deal with. And finally, the YouTube data. Well, I've made life slightly hard for myself in terms of YouTube data. If I just wanted the name of the channel, the number of views and subscribers, this would be fairly easy. But I wanted to also target what is the most recent video and what's the number of views on that video and how long has that video been up. And that requires me to do 2 other web service calls to get to that data. So I'm using channels to get me the name, the views and the subscribers. Then I'm using the playlist items, which I'm targeting a special playlist, which is actually all of the videos you've uploaded are automatically added to. So I can pick the latest video from that and get its publication date. And then I use the videos web service in order to get the views and like number for that video. For the YouTube service, I really did need to go and do some evaluation of how that worked, because we've actually got 3 separate calls that I need to do in here to understand the channel itself, to understand the playlist off of that channel, so that I can actually find some details about what the latest video is, and then the video itself. So that really did mean that I needed to explore a little bit and understand how that worked, what the keys were and where I needed to pick those keys up from. So that gave me enough to be able to play around with these three separate web service endpoints: channel, playlist and video, and to put this rather more complicated structure in, where we can basically go and first of all get some details about the channel, including the snippets, statistics and content details. The snippet will give us the handle for the name of the channel. The statistics will give me the number of subscribers and number of watches. And then the content details, well, that will allow me to pick up the default playlist of everything or the most recent video that's been uploaded. And so we're then just going to process that as we processed all of the other web service responses. Then go and trigger some of the other updates in here. So I'm triggering update playlist and update video, all from this. And the update playlist is then going to go and trigger another web service call to find that playlist, to find the latest video. And then update video is going to trigger and another web service to go and find the number of likes and views on the latest video. And so demo time, and we're basically just looking at the output coming out of standard out on my Pico 2W. So we can see it's joined to the Wi-Fi and it's going to print out some time information as it's got SNTP back, and it's giving some status information over to the screen as well. And then we can see the web services begin to call, and each of those web services runs, and as it finishes it sends the data over as a JSON structure to the screen for it to be able to update. And that's why you see the screen go through some updates as status data becomes available as those web services complete their calls. And finally there you can see that it's reporting that the Wi-Fi is up and the web services are all run okay, and it's basically going to go to sleep until it's next time to schedule to run another service. My approach in this video of using that Pico 2W to run the web services for a companion screen, I think is reusable across a number of projects. From a development point of view, the separation of concerns helps me, I think, build this quickly, along with having full debugging tools available to me if I'm using a Pico 2W, to be able to understand what things are going wrong, and they do. I'll definitely be using this approach again, I think. If this video helps you out or sparks ideas for your own projects, consider dropping me a tip using that super thanks button below the video. Alternatively, there's a payment link in the description. I'm saving these up to get myself over to the open source conference in San Francisco in 2026, and every contribution brings me one step closer to making that journey. And I'd love to meet some of you over there too. This isn't the first time I've looked at web services from a Pico platform. I've put together a playlist of some of my other examples that you might like too.